the general solution for the given matrix, for the given system. So you're given the system in form of vector x prime. First, you need to find a minus lambda I. What is a? Let's call this matrix A. Subtracted with lambda I, that gives you this matrix. Then find the determinant of it. So I'm gonna work across the row here. So you have -1 minus 1 lambda times cover this column in this row, -1 minus 1 lambda times 6 minus lambda minus -2 times 0, which is 0, minus 4 times cover this row in this column, 4 times 6 minus lambda minus -2 times 0, which is 0, plus 2 times 0, which is 0. Then you distribute this out, simplify it, that you will get this, set it equal to 0, and then solve for lambda. You will get lambda equals 6, -5, 3. So here's your eigenvalues. With each eigenvalue, you will get an eigenvector for it. So let's find out what those eigenvectors are. For lambda equals 6, plug it into this matrix. That gives you this matrix augmented with 0. Normally you would reduce it down to like this one. Normally you would reduce it down to this base matrix, right? In this case, for the first row, I want to get 1, so I divide the whole row by -7. Okay, and then now this become a pivot, so I want to make everything below it 0. So here I still have the 4. So first I divide the first row by -7. Then you would rewrite the second and the third rows, but in order to save time, I'm going to make this entry become 0. So multiply, after you divide this by -7, you will get this, multiply this by -4 and add it up onto this row. You will get 0, -33/7, -6/7, and last row rewrite it. Okay, so here you got the pivot and all entries below it 0. Now for this one, make this become a pivot, which is 1. So multiply by -7/33, that gives you this. Now make this become 0. Okay, so after you got this one, multiply this by 4/7, add it up onto the first row, that gives you this. Okay, as you can see, you have k1 minus 2k 2/11k3 equals 0. Then I found out that k1 equals positive 2/11k3. For this one, k2 equals -2/11k3. So if I choose k3 equals 11, then I got k1 equals 2, k2 equals -2. Then my vector k1 is 2, -2, 11. Now you are going to do the same thing for lambda equals -5. Plug it into here, and then you will get a new matrix, which is this, augmented with 0. Okay, now for this matrix, I see that 11k3 is 0, so I can find out k3 equals 0 very quickly. Okay, so let's see if I use the first equation. I will have positive 4k1 plus positive 4k2 plus 2k3 equals 0, and since k3 equals 0, ignore this one. Then solve for k1, I got k1 equals -k2. Now choose k1 equals 1, then k2 equals -1. You can choose whatever value for k1 as long as it's not 0. Now, and then my vector k2 is equal to 1, -1, 0. Again, you are going to repeat this process one more time for lambda equals 3. Plug it into I minus lambda I, you will get this matrix augmented with 0. Alright, so from the third equation, I found out that k3 equals 0. So this is similar to this one. So use the first equation, -4k1 plus 4k2 plus 2k3 equals 0. So k3 equals 0, ignore it. Solve for k1, I got k1 equals k2. Again, choose k1 equals 1, then I found out k2 equals 1. Then my vector k3 equals 1, 1, 0. Now here's the most important step, which is writing down your final answer. Because you have 3 distinct eigenvalues, so your final solution will be given in this form. Vector x equals c1 times k1, k1 is this one. times e to the lambda 1t. Lambda 1 is 6, so you have e to the 6t plus c2. K2 is this, e to the lambda 2t. Lambda 2 is negative 5, so e to the negative 5t plus c3 times k3, which is this, times e to the lambda 3t. Lambda 3 is 3, so you have e to the 3t. Right, so here you find your answer. That's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.